Let's look at some standard limits and proofs for some of them. So limit as x approaches a of x to the power of n minus a to the power of n by x minus a. This is equal to n a to the power of n minus 1. Now here for all n belonging to rational numbers. So since it is rational numbers, we need to show or we need to prove for positive integers, negative integers, 0 and fractions. Okay, then once we have proved all these 4 cases, then we can say that this statement is true. Okay, let's take it one by one. For positive integers, limit as x approaches a, x to the power of n minus a to the power of n by x minus a. Now, if you actually do the division of this, what you will get, and you know how to do this division, just write it minus n to the a to the power of n and start dividing. So you have to multiply it with x to the power of n minus 1. Yes. So when you multiply it, you will get x to the power of n minus a x n, a x to the power of n minus 1 minus plus, right? So here you are left with a x n minus 1, right? Now let's take, you have to multiply it with a x n minus 2. So multiply it, you will get a x to the power of n minus 1 minus a, you will get a x n minus n to the power of n minus 2 minus plus. So what do you get? Minus a square n minus 2 minus a square a to the power of n, again plus a square now n to the power of n minus 2. So you will get what? A square n minus 2 minus, this is, remember, this is a to the power of n, right? Multiply it with a now, a's cube it becomes, a cube n to the power of n minus 2. So now plus plus, this gets crossed, a cube n to the power of n minus 3. So with this itself you can see a pattern emerging. So what will happen is you will end up with x to the power of n minus 1, and here a is to the power of 0 plus a x n minus 2 plus, this will actually become, should actually become 3. Anyhow, if you do the division properly, this is what will emerge, a to the power of 2. This is 1, 2. So a's power will keep increasing and x's power will keep decreasing. Till when? Till a's power becomes 9 minus n minus 1 and x's power becomes 0. So now again let's take the limit now. So when you take the limit, what will happen? X will become a. So a to the power of a to the power of 0, a to the power of n minus 1 plus a to the power of 1, a to the power of n minus 2 plus a to the power of 2, a to the power of n minus 3. Finally it will become a to the power of n minus 1, a to the power of 0. Now let's do the exponent arithmetic. A to the power of n minus 1 plus a to the power of n minus 2 plus 1. So n minus 1 plus a square, a to the power of, sorry, not a square, a to the power of n minus 3 plus 2 minus 1. Like that it will keep going till we reach a to the power of n minus 1. How many times is this being repeated? A to the power of n minus 1. Repeated addition, remember, is multiplication. So n a to the power of n minus 1, which is nothing but the RHS. Now let's look at for the negative integers. Negative integers. Okay. So let n equal to minus m. Okay. So let's start. Limit as x approaches a, x to the power of m. Now remember, it is not m minus m, minus a to the power of minus m by x minus a. Limit as x approaches a, 1 by x to the power of m minus 1 by a to the power of m divided by x minus. Okay, so limit as x approaches a. Let's take the LCM. X to the power of m, a to the power of m, cross multiply. So a to the power of m minus x to the power of m multiplied by 1 by x minus. So limit as x approaches a. Let's see in our right hand side, not right hand side, what we want is x to the power of 1 as positive and a to the power of m as negative. Here it has got reversed. So how do we unreverse it? Let's take the minus outside. X to the power of m minus a to the power of m. If you again remove the bracket, x to the power of m will become negative and this will become positive. X to the power of m, a to the power of m by x minus a. Now x tends to a. Now let's take this expression to the above x minus a. So minus 1 divided by x to the power of m, a to the power of m, x to the power of m minus a to the power of m by x minus a. Now let's take the limit. So this becomes minus 1 by a to the power of m, a to the power of m times. Now this we have already shown in the previous for positive integers. This is equal to m a to the power of m minus 1. Now let's do the arithmetic. Minus a minus 2m times m a to the power of m minus 1. So this is equal to minus m a to the power of minus 2m plus m minus 1. So this becomes minus m a to the power of minus m minus. Now remember, n is equal to minus m. We start off with this. So let's substitute minus m with n. So which is what we needed to show. Third case is n equal to 0. So limit as x approaches a of x to the power of n minus a to the power of n by x minus a equal to n a to the power of n minus 1. We have to show this. Let's take this limit as x approaches a. So here n is 0. So x to the power of 0 minus a to the power of 0 by x minus a. Now remember, this is the tricky part. They both are equal in the numerator. Why? Because anything to the power of 0 is 1. So both are 1, x minus a. So limit as x approaches a is 0 by x minus a. So limit as x approaches a is 0, right? So which means we can write this, and this is the tricky part, we can write it as 0. But any operations we do with 0 as far as multiplication is concerned will be the same. So we can say 0 times n to the power of n minus 1, which is equal to a to the power of n by. Here n is what? n is 0. So, or 0 is n. So, we can say n(a) to the power of n minus 1. A little bit tricky, but straightforward. You come up to here, and this is where you have to realize that you can do some additional things with 0. Multiply it with a to the power of n minus 1. It is still 0 overall. And remember that we have said n is equal to 0. So instead of 0, write n. Same way, we can do it for fractions. Okay, I'm not going to do the fractions part. Let's do some exercise based on this. The moment you look at 243 and especially x to the power of 5 in combination, you should realize that you can rewrite this statement as x to the power of 5 plus 3 to the power of 5 by x plus 3. And also you should realize that we need a negative number as far as the, see here, as far as that standard limit is concerned. So limit as x approaches minus 3, x to the power of 5, we want this to be negative, so put minus. But overall we want it to still be positive, so take the minus in. And remember, minus to the power of 5 is always minus by x minus minus 3. Now that we have it as per our standard limit, we can take the limit. Remember, this is equal to n(a) to the power of n minus 1. Here n is what? 5 times. A is what? Minus 3 to the power of n minus 1. N minus 1 is 4. 5 times 9. 9 9s are 81. 5 1s are 5, 5 8s are 40. So 405 is the limit. Let's take the next one. Don't get frightened when you look at something like this. X to the power of 3 square root of x minus 27 root 3 by x minus 3. Okay. Limit as x approaches 3. This you can write it as 3 and 1 by 2. 3 cube 3 1 by 2 by x minus 3. Limit as x approaches 3. This becomes what? X to the power of 3 plus half minus 3 to the power of 3 plus half by x minus 3. So limit as x approaches 3 becomes x to the power of 7 by 2 minus 3 to the power of 7 by 2 by x minus 3. Remember the pattern, it is as per the standard limit. So now we can take the standard limit, n(a) to the power of n minus 1. So n is what? 7 by 2 times a. A is what? 3. N minus 1. 7 by 2 minus 1. So 7 by 2 times 3 to the power of 2 1s to 7 minus 2 by 3 to the power of 5 by 2. Now this can be written as 7 by 2 times 3 to the power of 5 1 by 2. Now here 4 of the 3's can be taken out as part of the square root. Remember, this can be written as 3 to the power of 5, which means that it can be written as square root of 3 to the power of 4 times square root of 3. So which means that this becomes 3 square root 3. So this becomes times 9 root 3. 9 7 is 63 by 2 root 3. So this is the limit. Now let's take the next one. x limit as x approaches minus 1, x to the power of 9 plus 1 by x 14 minus 1. Now what do we do? Just remember the pattern. So limit as x approaches minus 1, x to the power of 9 minus 1 becomes plus 1 to the power of 9. It still remains minus, divided by x to the power of 14 minus, remember this should still be negative, so minus 1 to the power of 14. Now because it is a even number, it will become plus. So limit as x approaches minus 1. Now let's do something different. Let's divide both numerator and denominator by x minus 1, right? X minus 1, okay? Divided by x to the power of 14 minus 1 to the power of 14 by x minus 1. We can do that. Divide both numerator and denominator by the same number. The overall still remains the same. And these two limits can be taken out separately. So limit as x to the power of 9 minus 1 to the power of 9 by x minus 1 divided by limit as x approaches minus 1, x to the power of 14 minus 1 to the power of 14 by x minus 1. Now we take the limit. Both the patterns are satisfying. The standard limit, a standard limit. So na to the power of n minus 1. So here n is 9, a to the power of 8. A is what here? A is minus 1 to the power of 9 minus 1 divided by same thing. So n is 14 times minus 1 to the power of 14 minus 1. So this becomes 9 minus 1 to the power of 8 divided by 14 into minus 1 to the power of 13. So 9 to the power of minus 1 to the power of 8 will make this positive. So 9 divided by 14, and this would make it negative, an odd number. So 9 divided by minus 14, which is minus 9 by 14. This is the limit. There are different ways in which a problem may be given. Sometimes you have to use some tricks, and the only way in which you will know those tricks is by actually practicing a lot. Let's take the limit as h approaches 0 of h by r plus h to the power of n minus x to the power of n. Now x plus h. Okay, so now what do we do with this? Looks tricky, but the pattern is still somewhere visible. So what can we do? Let's do one thing. H approaches 0. Let's take the h, or in other words, let's divide both numerator and denominator by h. So this gets divided by h, and this gets divided by h. Possible? Yes. So h by h becomes 1 above, and this becomes x plus h to the power of n minus x to the power of n by h. Okay, here I don't really know how to proceed. So what I'll do is, let's see whether we can manipulate this itself, right? So let's say, because here I have x plus h, so x plus h if I make, if h is tending to 0, x plus h will tend to what? Will approach what? It will approach x. Yes, okay. So I change the limit itself logically. and say x plus h approaches x. So which means I can now rewrite this statement as x plus h to the power of n minus x to the power of n divided by, now this h should still be h, but in the denominator here I want x plus h. So x plus h, right? But I want it to remain h. So I minus x, right? This x minus x becomes 0. So I'm left with h, which is what it should be. But to make it conform to the standard limit, I'm doing this. So now what happens? Limit. Okay, I've got the standard limit now. So I can directly take the limit. So what is the, remember, na to the power of n minus 1. So 1 by n is what? N is n itself. A is what here? A is x and n is n itself. So n minus 1. So in this limit, that h totally disappears. Okay, this is a very important one, because when we go to the next topic, something similar to this we would be looking at. I think that's enough for today. Bye for now. Please go to the about page of my channel, and here you will find various links for each topic. These are Excel workbooks which I have been using in many of my videos. Download it and practice.